Okay, now we are going to talk about free body diagram. Free body diagrams basically shows the total forces that are acting on a certain body. So for instance, we have a box. Okay, so usually for the box we will have a downward force, right? What we call its weight. Right, its weight is usually measured by mass times the gravitational pull. Right, for instance, in your case, the mass is 7 times 10. So this is the downward force, 70 Newton. This is the downward force. And then after that, in the question also, we have another force. That force is given to us to be 25 Newton, right? To be 25 Newton. 25 Newton, right? Now what I want you to note is this. This force for the weight is vertical. So in this case, it doesn't have any X or Y component like this. It doesn't have any X or Y component because it is vertical, downwards. So it is very clear cut, it's downwards. But now what we can talk about is this 25 Newton. This 25 Newton is a diagonal force. And because it is a diagonal force, it has X and Y components, right? And that is what we have to find. When we talk about free body diagram, this is what we are talking about. Just a normal box with all of the forces acting on it. The weight and then the force pulling it up. So for instance, now I have this box. I say I want to find part A, the force that the ground exerts on the box. Right? So I want to find the force that the ground exerts on the box. Right? Two things you have to take note. One, for the first thing, right, you have the weight, 7 Newton. Right? This is the downward force from the box. The second, right, we know that this 25 Newton, earlier I mentioned, have two components. It can be broken up into the X component, the one that pulls it sideways, and then it can be broken up into the Y component, the one that pulls it upwards. Okay, so total downward force is 70 Newton, right? Or I wouldn't say total, I would say downward force. We have a downward force that is 70 Newton. But what about this upward force here? We have to find it out, right? And I believe the angle they give you was what, 42 degrees, is it? Okay, just use this as an example. Okay, imagine this is 42 degrees. So how are you going to find Fy? Right? I think if you want, you can even memorize it. Fy is always equals to 25, right? The force is 25. 25 sine 42 degrees. Okay? So let's find out what's 25 sine 42. It is 16.7 Newton. So what is the net force? Right? We have this box. The downward force is 70 Newton. The upward force is 16.7 Newton. So what is the net force? So you take the downward force minus the upward force, because it goes in opposite directions, so it cancels out each other. So what's going to happen is going to take 70 Newton minus 16.7 Newton, and what you get is 53.3 Newton. Now this is the example that I'm going to give you. Okay, so basically the whole idea is this: whenever you have the box, when you want to find things like this, the force that the ground exerts on the box, what you have to do is you have to find what is the downward force and what is the upward force, if any. In this case, there is an upward force because of this 25 Newton, and it can be broken up into the horizontal component, the Fx, and it broken up into the vertical component, Fy. So this is the net force.